Today we're going to talk about solving compound inequalities, and by the end of today's lesson, we'll answer the question, how do we solve and graph compound inequalities that contain the word and? So what is a compound inequality? A compound inequality is when two inequalities are considered together. They are connected using the words and or the word or. So and or can be used. So here in this example, we have h is greater than or equal to 52 and h is less than or equal to 72. Now down here below, this is another way to write the same thing. We read this as 52 is less than or equal to h, which is less than or equal to 72. This guy is the same thing as breaking them up and using the word and. So you have to recognize that they are the same thing. We can also have using the word or, so x is greater than or equal to 49, or x is less than or equal to 30. When we're dealing with a statement involving the word and, both parts of the inequality need to be true. So basically, the number we're thinking of, h, has to be in between 52 and 72. So it has to be a true statement. In the or statement, the letter x, or the number that we're substituting with x, has to be either bigger than 49 or smaller than 30, or equal to. So only one of those statements needs to be true in an or statement. So when we are dealing with an inequality or a compound inequality that's using the word and, we call their graphs the intersection. So the intersection is the graph of two inequalities connected by the word and in order to do this, to find the intersection, we need to graph each inequality individually and look for where they intersect. So here, if we had x is greater than or equal to 3, notice we use a closed circle because we have the greater than or equal to symbol. And we shade to the right because x is bigger than 3. Then we also have x is less than 7. So we use an open circle because there is no less than or equal to symbol here, and we shade to the left. Now if we were to put those two together, remember, you can write it either way. X is greater than or equal to 3 and x is less than 7. Or we can write it like this. 3 is less than or equal to x, which is less than or equal to 7. If we were to just smush these two graphs together, or really just graph them on the same number line, we'll have this piece right here, and this is called the intersection of the two graphs. So here's example 1. The directions say solve and graph the compound inequality. We have 6 is less than or equal to r plus 7, which is less than 10. And now remember, this is really like saying that this is a compound inequality connected with the word and. So when we solve this compound inequality, we're going to do what we do to one side of the equation to every piece. So imagine drawing your lines down both inequality symbols instead of just one. So typically, if I wanted to get the r alone, I would subtract 7 from both sides. But now I have an extra side here, so I'm going to subtract it from that side as well. 6 take away 7 is negative 1. I keep my inequality symbols the same. I'm left with r. And 10 take away 7 is 3. So really, if I'm looking at the inequality symbols here, I have negative 1 is less than or equal to r, but remember we like the variable to be on the left, so I'm going to flip it. I flip my inequality, so I have r is greater than or equal to negative 1, and if I were to graph that, I would have my negative 1, 0, negative 2, I would have a closed circle, and I would shade to the right. But now we have a second inequality. R is less than 3. R is less than 3, and if I were to graph that, I put my target number in the middle, 4, 2. This one will have an open circle, and I will shade to the left. So imagine now we're going to do both of these graphs on the same number line. So I put my closed dot on negative 1, and I shade to the right. I put my open dot on 3, and I shade to the left. And there is our intersection. Here is example 2. At this point in time, you're going to pause the video. You're going to try and solve these inequalities and graph them, and then you will push play and watch the solution done out. So push pause now. Okay. So here we're going to solve each inequality independently of each other. So here 5h take away 4 is greater than or equal to 6. I'm going to add 4 to both sides. And I have 5h is greater than or equal to 10. I divide by 5. And I have h is greater than or equal to 2. And then I have 7h plus 11 is less than 32. So I take away 11 from both sides. And I have 7h is less than 21. I divide by 7. We're not dividing by a negative, so I don't have to worry about the symbol flipping. So I have these two inequalities. So let's graph h is greater than or equal to 2. So here's 2. Since it's greater than or equal to, I put my closed dot. And greater than or equal to has got to be this way. Okay? And now let's graph h is less than 3. So that's an open circle on 3. And less than is to the left. And it's that way. So here is our intersection. Okay? That's our graph. And now here is your did you get it problem. This is very similar to the problems we have done in this video. Please have this ready for tomorrow's class where you will check your answers when you come into the classroom. Have a good night.